Welcome everybody to our seminar, our second seminar for VRC, a strategic approach. So, for those of you who are new, we had a lot of people sign up for this one, about 100 people. So I'm sure we're going to have a few more trickling in as the time goes on. Ooh, there we go. Yep. So Kai, can you stay on top of adding people if they join the session?
Yeah, I'll take care of that.
Thank you, sir. So, for those of you guys who are new, welcome to VEX VRC, a strategic approach. This is going to be a really fun time where we kind of learn how to break down games and understand the dynamics of games beyond just scoring points. Ooh, where did I? Okay, that's very odd. We'll try that again. This time with success, hopefully. Okay, we're trying that again. Sorry. So for those of you who are new, welcome. Additionally, if you have not yet, we do have our previous seminars available on our Nova Systemic YouTube channel. I would highly recommend, if you have not, if you haven't yet, please do make sure you go through and watch those videos. They're very useful. They cover a lot of different content. As a reminder, every week it's going to be a different type of topic that we're going to cover and a different game that we're going to cover. So it's very beneficial to go on and cover that stuff. Yeah. So if you did get the chance to, it's going to be super helpful to have watched those kind of in order, because they do kind of build on top of each other a little bit. If you haven't, it's fine. Just click the link, like, comment, subscribe if you would like to. It lets us know how successful these seminars are doing. So definitely helps us continue putting these on in the future. So my name is Afnan. I'm going to be hosting this. I've been involved in VEX Robotic since about 2011. I've been very active in the community as such. Kai is my co-host today. He's also very cool.
I've been doing VEX since 2015. And right now I'm just coaching a IQ team, 2 IQ teams actually. I've been coaching for 2 years, so there's also that.
Yeah. So, but we're here today to kind of share our knowledge and our ideas and opinions with you guys. Hopefully you guys can kind of grow from that. So before I continue, Nova Systemic is pretty cool. I might be biased, but I think they're pretty cool. We do a lot of stuff. So right now we're doing our seminars. Excuse me. So that's these 1-hour sessions that we go online and we kind of teach you guys a specific topic. If you guys looked at when you signed up, there were actually a lot of different seminar topics. So everything from VRC, VEX IQ, we've got, cybersecurity, we've got rocketry, we've got a lot of different things. And there's a lot of different STEM opportunities that we have for you guys, including summer camps. So as I previously mentioned, the new game releases this Saturday, and on release, that's pretty cool. We're going to be, at our next meeting afterwards, we're going to be discussing it for a bit, but there's actually a summer camp that's specifically designed to spend the entirety of the camp teaching you guys and helping prep you guys for this season's game, right? So we have a bunch of different summer camps. We've got everything from robotics, strategy, we've got coding, cybersecurity, basic STEM concepts, all of that. So I would heavily recommend you guys look into that. We host robotics tournaments, so that's one of the things we do. I personally am the head referee at a lot of the robotics tournaments in Northern Virginia. I'm one of the head referees at Night at the Museum. I'm one of the head referees at Worlds, so I'm really active in that sense. We try to maintain that level of activity.
To address the questions of Shay Ventura, camps are still on. We're moving it to online camps instead of in-person camps, but we're gonna upload information on that really soon. One of the best way to follow is to either follow our blog. I'm going to send the link later on, or you can just follow us on Twitter at Nova Systemic. So, yep.
Thanks. Okay. Yeah, unfortunately, the COVID-19 has kind of changed our plans for our summer camps as we traditionally do them. So as Kai mentioned, we are going to be uploading resources as they come out. So as the information comes to us, it'll come to you guys. Yep. So robotics tournaments, we do STEM. That's our big tagline, right? So if there's anything STEM involved, you could probably bet that we're going to be doing it. Everything from, like I said, teaching summer camps, robotics competitions. I think we also host TSA events sometimes. We just try and make sure that we're doing our STEM push. So everyone in Northern Virginia, everyone, wherever we can reach can be involved.
We hosted TSA VEX National Championship last year. So
yeah, it's pretty cool. So, if there's any questions you have, here's the email, systemic@nvcc.edu. And, if you have any questions as to what camps we have, what are the details on the release dates, what are the details of our online stuff, anything you got floating around about Nova Systemic, you can ask a few questions and we'll make sure to kind of try and address whatever we can. Boom. So our overview, if you forgot, here's a reminder what we're going to be doing. Our goals are learning how to break down a VEX game. So like I said, this is more than just score points and win. We're going to break down the dynamics and how we actually approach. We're also learning how to form strategies. So a lot of people, when we talk to, are, what's your strategy? I'm just going to go up there. I'm going to turn my robot on. I'm going to do an autonomous. I'm going to score some points and win. that's not exactly a strategy. That's a loose hope that you hope happens, right? Like we hope we win, but strategies are how we get to that end goal. So we're going to talk about that. We're going to practice our critical thinking and be more prepared for next season, which is approaching very, very shortly with a game release. So, we're going to do a lot of that. Our approach for that. So how do we achieve this? We're going to break down one VEX game per meeting. We want you guys to have a variety of examples you can look to. And so for that reason, we're doing a bunch of different ones. We're going to read the rules. That's the best way to understand how a game plays. It's the best way to understand what's legal. Very important thing there. So we're going to read those, and we're going to watch some gameplay. There's a lot to be learned from previous examples and previous things that have happened. So we're going to make sure to cover a lot of that. And understand why some approaches are better than others. There's more than just, creating a strategy and running it. We need to understand why our strategies are either objectively better or objectively worse than what we see, and why a world champion is a world champion as opposed to, any other robot in a regional competition. So our focus is today's plan. So what we're going to try and do today is cover a lot more of the more immediate stuff that you're going to see kind of as the early season happens. So can a game have no autonomy period? That's an interesting question. Kai can definitely answer that.
So you can have no autonomous period, but if you don't have autonomous and you go to bigger tournaments like states or, nationals and stuff like that, you're definitely not going to get the bonus point. So highly suggest having autonomous period inside your game. Plus, there's also skill. So autonomous skill is a big part, very big part of your total points. So highly suggest having autonomous.
Yeah. All games will have an autonomous period. It's your choice whether you take advantage. And as Kai mentioned, you definitely should take advantage. So our plan for today, we're going to talk about design convergence. So that's a really popular term. I don't know if you guys are familiar with it, but we're going to go into what does that mean. And we're also going to be talking about what it takes to make a good autonomous. So right on key with that question. After that, we're going to break down a game and we're going to have some discussion. So what I want you guys to kind of think about is why we're doing design convergence and why we're talking about making a good autonomous when that game is about to release on Saturday, right? So it's a very important thing to understand that these are concepts that will kind of appear early season, and they're very important that you kind of take advantage of it. So everything we're covering in this session is supposed to kind of guide you towards being so much more prepared for this immediate Saturday release. That's why we're talking about it, right? So when I think design convergence, I think Starstruck, because that game, literally every robot looked the same. And again, we're going to talk about that. That's where we get that. Making a good autonomous, I have like an example autonomous here. Ooh. So it's just, having something that works consistently, having something that can score more than just a few points, and something that is very time efficient in that sense. So we're going to talk about, how to get from nothing to kind of like that. Go on to our next slide. So design convergence, let's talk, right? What is design convergence? So design convergence is the trend of most robots looking the same. And normally we don't see this trend until later season. So what you'll notice is by your state tournament, by your world tournament, or maybe even some of the later regional tournaments you have, a lot of the robots look pretty much the same. There's like small differences here and there, but for the most part, they look the same. Traditionally, this is a concept that you don't experience, or this is like a thing you don't normally notice until the later season. What we have noticed is this season in particular, with the RI3Ds and the early people releasing all their designs and ideas and opinions, and that like large push of like the social nature of robotics, a lot of robots tend to look the same from day one. We had the Goofy design released this year for Tower Takeover, and boom, first tournament, second tournament, every robot that was putting up points pretty much looked like that. So we're going to talk about, well, you need to understand that design convergence is not inherently bad. You hear a lot of people go, this is an ugly thing. I hate design convergence. People aren't being creative. People are just, copying and pasting what they see on the internet. And you need to understand that design convergence, although does mean a lot of things look the same, there are reasons for that. And it's not inherently like a bad thing for you to have a robot that looks like other people's robots. You don't just go, oh, well, this is another just another Goofy bot. Who cares? You got to kind of think about that, right? And so when I say it's not inherently bad, I mean, it definitely helps, right? People get a rough idea of what is good. When you see a robot and there seems to be like an established meta there, you're noticing the meta exists for a reason, right? We don't just push a meta to something that's like a bad robot. The meta is there because it's effective. So when you're looking at design convergence, you're looking at what people in the broad community, not just like, your school, not just like your local county, your local state, definitely the world. You see what people, the different perspectives from around the world have kind of decided that this might be our most efficient approach. So, when you look at design convergence, you're looking at what the general group has come to the consensus of saying is this is the best, right? And there's no point in reinventing the wheel if the current implementation works well. Every year you don't have to say, well, I'm going to do something on my own. If you've noticed a trend that is being very, very productive or very efficient, you can take advantage of that, right? It's one thing to innovate, and it's really good to innovate so you can get a lot of different ideas, because sometimes if the meta design gets to like this level of productivity or this level of performance, you can get to the next level by maybe making something else, right? But if you're making the same thing, chances are you're going to end up right about the same level as where that meta is. So you definitely want to be the person who's like above the meta, either at the top of the leaderboard or beyond that. So sometimes innovation is required, but there's no point in saying for Starstruck, if you look at that game where every robot had like the same claw back dump action or forward dump action, there's no point in saying, I think I'm going to develop some third party way of pushing them under that barrier just because I don't want to do what everyone else did. I've most definitely seen teams lose matches 1v none because they said they weren't going to hop on the meta bandwagon, as they called it, and said that we're not going to sell out, we're going to do our own thing. It's not really selling out when you think about how you do it, and we're going to talk about how to take advantage of it actually. Boom. So it establishes a baseline of what is considered good. Like I mentioned earlier, the meta exists for a reason. This design convergence is because people have decided that I look at this design and I see success, I see points being put up. That's kind of your baseline right now, right? Because if you know that the popular design that a lot of people have, like I said, achieved this level of success, then that's kind of the baseline. You've redefined what your 0 point is. It's not just like a push bot that can't move. I mean, maybe it is, like sometimes that happens, right? But that if you can just see a robot, kind of copy paste, make something similar, make something different about it, other people can too. And that becomes your new baseline of what you would expect another robot to be able to do. So your robot should definitely at least achieve that baseline, right?
One of a very good example of this is if you look at Nothing But Net, everybody basically have the exact same design of a flywheel. At the very beginning, some teams have design of pinions or some kind of push rod that can launch the ball into the net. But at the very end of the season, pretty much every good team has a flywheel design. So that's like same thing with not inventing the wheels. If the current implementation works pretty well, you should definitely go with it.
Yeah. And so James asks, what if your robot is totally different but still really good? And that's fine. When you make a different robot, that's fine. Innovation is a huge part of the game, and being different does have its payoffs. But when you are different, you need to make sure that that robot that is different is also able to compete at the same level. I've had teams I've worked with, I've coached, I've been on who say, we're going to build a totally different robot and it's not going to look like this. Not because it's better, but just because it's different. And those are two very important things to understand. Being different for the sake of being different does not necessarily put more points on the board. Being different but effective, and perhaps more effective or just as effective, that's totally fine. That's totally cool. Is design convergence similar to meta, or are they two different things? Yeah, so design convergence and meta are rather similar, just because design convergence is the kind of like, I guess, the more formal term for just meta. When you see that all robots kind of end up looking the same. And you'll notice the same thing, like if you go to different social media platforms, like you'll notice that a lot of the time, the interface on your phone looks the same. You go to a lot of different websites and, they've got like a little navigation bar on the top, they've got like a bunch of different like things put up on the left side and on the right side, how they orient. That's design convergence, just like a really generic term for meta. So here's the danger of design convergence. It can lead to settling for less. So that great question that was just asked about, what if your robot is different but still good? This is where you kind of look into that, right? So people will build the robot, they'll go online, they'll say, boom, I just saw this robot put up like 85 points. I'm definitely going to build that, right? And then all of a sudden, what you realize is people say, well, if this is the level of performance that it's achieving, that's the level of performance I want. I'm going to make that and I'm going to achieve that level of performance. And you have to understand, when somebody originally creates a design, they've worked with that design and they understand, the unique aspects of it, what makes it the way it is. When you just kind of go online and say, I'm just going to make that, you tend to end up with getting almost a watered down version of that. Or, okay, let's say you don't get a watered down version of that. You get the same level, but you don't think about, what if I wanted to be better than that level, right? If we're kind of trying to be the best in the world, then we don't want to say, hey, I'm going to be just as good as this person. We say, hey, I want to be better than that person. You know, I'm not settling for just putting up so many points. I'm settling to I'm going to do even more than that. I'm going to double their points. Question, how would you justify building something that everyone else is doing without seeming like you're just bandwagon copying other people during judges interviews? So the justification of, you know, building something that everyone else is doing without just hopping on the bandwagon comes from your unique choices you make to do it. And actually, we're going to talk about a little bit of that on the next slide as to, you know, how you justify what you build. And I think in the previous session, like last week as well, we talked about like making sure that everything you do has your justification behind it. In theory, if you have justification behind your design, that's not just we saw it on YouTube and it looks cool, then you should be able to talk about, you know, why does it weigh as much as it does? Why are the wheels where they are? Why is the intake so wide or so thin? Why do you have this specific feature? But yeah, hopefully that answered your question. Becomes hard to differentiate good robots from bad ones. I don't know, like, if you guys ever noticed, but if you go to your state championship and, you know, you're looking at the robots, you kind of look, you get to like alliance selection time maybe, all the robots look the same. So how do you know which ones are good and which ones are bad, right? When you hop into the design convergence, into the meta, you are now accepting that, hey, there's a big just crowd of people. I'm going to be another one in the crowd. When, you know, world champions, people who are at the top, they don't necessarily sit in the crowd. You know, they're leading the pack. And so when you hop on the design convergence, you do run the risk of being hard to differentiate from bad robots. You know your robot's better than, you know, robot number 37, but how do you prove that? It becomes hard to show other people, right? And so we're going to talk about how to kind of go beyond just what we see. Yeah, so definitely, you know, Gina says design convergence is cool, but you can definitely justify your decisions by showing your progression and showing the ideas you've had. So it's a very valid point. Sometimes design convergence is not avoidable. So like this year we saw, you know, literally every robot, there were about like 2 different types of robots. We had our reversible 4 bars that would just pick up a stack and kind of put it on top. And we had our, you know, our goofy designs that picked up use side roller intakes to pick them up and put the stack up in the goal zone. And so sometimes it's not avoidable. You know, sometimes it's just been so tried and true that that's kind of what you're going with, and that's understandable. You know, honestly, sometimes you do need to realize that maybe, you know, the amount of work that people put into this have made this the best design. It is hard sometimes to kind of break out of that. Yeah, so just keep that in mind. I've definitely seen, from my years of experience, is at Worlds, you will see a total of 3 designs. About 3, maybe 4, but they're at like maximum I normally notice is 3, right? So if we look at previous years, you can see how, Turning Point had double catapult or linear puncher. And then we had like a few robots that maybe were designed more to take advantage of defensive play, right? When you look at a few other games, you'll notice that there are 2 or 3 trends that tend to be the same because, you know, the world starts from their individual perspectives and they shoot out and they see whatever they can come up with. Ideas that don't work, shot down, readdressed, try again, right? And through that kind of iterative process, the world comes up to say, you know, these 2 or 3 designs seem to be the most competitive. So it's definitely like a trend you'll notice. So we're able to put yeah, so you have your different opinions, and that's why we choose our different designs, right? So some people say that reversible 4 bars are better. Some people say that, you know, the goofy designs is better. Well, that's your opinion. That's your justification. Your justification is what you would do during your design interview. That's your justification you put in your notebook and say, hey, although the meta says this, we disagree. Or although the meta says this, you know, we agree because. So there's that. Know when it's too late to hop on the bandwagon. So please keep this in mind. I definitely made the mistake in my years of competition. You know, I still remember in Skyrise, you know, 2915A releases their 3 cube or their 2 or 3 cube, you know, needle. And I was like, whoa, this is amazing. This is the coolest thing I've seen. I'm doing that. That's going to be what wins. And, you know, it was also like a month before Worlds. So as you can probably guess, that did not pan out well for myself. But, you know, that's because it was too late to hop on that bandwagon. You need to understand that you have deadlines. There are time restrictions to these things. And when it is too late, it is too late. You sometimes need to understand that, you know, the amount of time I have is a limited resource. When I spend it, I don't get it back. And, you know, if it takes this person who achieves this much success with this design, how much time did it take them to achieve that level of success with their design? Although you can, you know, circumvent some of that time challenge by looking at what they did and kind of like, oh, they must have done this because this, and oh, they must have done that because that. You can't, like, you know, tune everything to your own making, because you definitely build things differently, right? So you require your own level of tuning. So you got to understand, sometimes it is a little too late. Ah, yes. So Gina asks, what if you came up with a really nice design and just put it off releasing it until it's too late for people to follow your example? That's definitely what I did. And that's definitely what people would do, right? So my theory, like, I don't know, call me like paranoid, but like my theory is, why would I release my design to the world until I have a design that's better than that, right? If I find out a design that's like, boom, top of the tier, like the best robot I can make, why would I openly put that out to the world to have them, make up the same design, unless I've already achieved the next step of that design? So when I see designs online, I automatically assume that, oh, they released this to the world, they're already on the next version, and they've just given the world the old version. I don't want their old version. I'm going to look at their old version and go, boom, 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 this is what's wrong with it, and this is what I can make better. I'm making their next version, or the next version's next version, right? Boom. So design convergence. How do you take advantage of design convergence? That's big, because you know it's going to happen. You know it's going to exist. We might as well take advantage, right? So boom, understanding that you will play with and against these robots. So knowing that these are robots you're going to see exist, these are robots that you're going to see on either on your alliance or against you, you need to understand what their capabilities are, right? So if you know that the Goofy robot from this year, which is like the most common design convergence, has trouble playing defense because you can, or has trouble against defense because you can just hit it from the back and all the cubes go flying out the front. You want to kind of make a note of that, right? Because that's what other people are going to be running. So you want to be proactive and ready to take advantage of that. Is it bad to start super early, have a good robot, but get burnt out and get over robotics and then game season? So the quick question is, is it good or bad to stop or to start building right when the game season begins? It's not bad to start. You definitely want to give yourself the most amount of time, right? Robotics is kind of a function of how much time you put into the grind, and the more you kind of put time into the grind, the more you get out of it. Yeah. See, so there's a lot of that. So figure out how the worst implementation of that robot works. If you know this is what everyone's using, then maybe you should figure out what the worst version of that robot could look like, right? Because you know that you might be one of the better teams in your state. You know that you might be the middle of the barrel. But you need to understand that, people are going to see that design and go, whoa, this is super cool. I'm making that. And there are going to be a lot of people who hop on that too late. They're going to say, this is cool, I'm changing it. And their coach is going to go, isn't this the night before the tournament? And they go, yeah, I'm doing it anyway. So understand that you're going to be allianced with these robots who, although might generically look like a version of that design converted or meta robot, they might not perform as well. So you definitely want to figure out, what is the worst this robot could perform at, because that is going to be your least expectation, right? You know that if you get an alliance partner who's like really bad, they might be a push bot. They might be just a claw bot. They might be the worst implementation of this meta design. Keep that in mind, because you're going to need to know how to play with that robot, right? Identify weaknesses. If someone releases a design and you go, this is super cool, you need to identify, is this going to be successful? Is this what people are going to jump to? And if you know that this is successful and you know that people are going to hop on that design, start finding weaknesses. You need to start figuring out, how am I going to beat that? If this was this much better, what could I do about this design better? If I end up making this design, how do I make it 10% better, 20% better? How do I score more? How do I become faster? Finding out how you can do that will help you be ahead of the meta, right? Everyone's going to be on some point right about here. You're going to say, well, isn't that a weakness they have? Like, I didn't think, people would want to do that because cubes would fall out of the robot or something. What if I did something else? And all of a sudden, you now have a robot that's similar to the meta design, but inherently better because you looked at those weaknesses. You didn't just copy paste and move on. Like popular ones this year were towers, right? The weaknesses. So yeah, so like you can identify, maybe if you have a super long tray that, it's going to be hard to drive and you can't drive around the towers from this year. So maybe that's a weakness you could identify and say, hey, maybe I'm going to design a long tray that slides out or expands, right? Maybe I'm going to design a tray that isn't so long but can still hold that many cubes. These are things you got to kind of consider, right? Figuring out ways to improve designs, either in implementation or theory, right? So when I look at a design, there are two aspects of that design: implementation and theory. So implementation is the literal, like, screw, how do they put it there? Why do they put it there? Wheels, why are they here? How are they here? These type of questions are our theory, or in theory, this robot's supposed to score a 10 stack, and how does it play the game? The implementation is, okay, it scores a 10 stack by using this intake and this tray mechanism. Right. So figure out what is the hole in their strategy and what is the hole in their implementation of their strategy. Because once you figure out the weaknesses that they've got in their, in their theory or their implementation, you can take advantage of those and you can make a better version, because that's going to put you ahead of the meta, right? If you figure out that, and one thing that I thought was like a weakness this year, was robots that had these like goofy style intakes, these like long tower, long trays in the background. These tails are so long, but they get caught on other robots. They can potentially reach into the inner protected zone, like the volume of the inner protected zone. And even if you didn't like mean to, you just turned your robot and you ended up getting disqualified as a result, right? So maybe that's the thing you want to think about and say, oh, well, what if I made my train not so long? Or like something how robots were easily defended by just pushing the back of your robot against their tray, and all of a sudden you just launched all their cubes, right? That's totally legal defense, but they didn't do anything to prevent you from that. So, what if there was a design this year that prevented that from happening? What if you spent a few minutes thinking about that? You could have been on top of the meta because it would not have been possible to play defense on you. Understand why specific design decisions were made, right? So no design decisions are made arbitrarily. And if they're made arbitrarily, you might be doing something wrong, right? If there's a design decision made, it's because it makes the robot better. Why would you make a decision that you don't know makes your robot better? You just kind of like, oh, it looked cool. Oh, it was like a thing I did, right? Now, you do things, you decide things like meticulously. You think about it and say, why am I going to put this flywheel here? Why am I going to, like for nothing but net. Some people had flywheels that shot forwards. Some people had flywheels that shot backwards. When I say forwards, backwards, I mean, with relation to the side of their intake. So shooting in like line with their intake or shooting behind their intake. Well, those are decisions you have to make. They change the way you play the game, and you should understand why that decision was made, because once you understand that decision, you can take advantage and say, oh, well, I disagree with that decision. I'm going to actually do something else that's not the meta, but I think it'd be better because. Yeah, so like Gina mentions, like, a lot of robots this year did look like the goofy design that was released super early, but they weren't as good because they just copy pasted and they didn't think about the decisions that were made. So that's definitely a good point. So predict how much effort it would take you to make a better version of that robot. You want to this is where you kind of want to size up, right? You recognize that this is a good design. You recognize that people are going to take it. Maybe you want to size up and say, hey, it took these guys 3 days to make that robot. How would I make it better? How much time would it take me to make that robot, but at a good level, right? And you want to keep that thought in the back of your mind, because what if the design you are currently developing, does not achieve at the base level what that other design could? Because remember we mentioned you want to keep a rough idea of what that robot can achieve, right? Like that whatever that meta design achieves is kind of like the base level. That's the new zero. That's what everyone's going to be able to achieve. So you should be able to achieve at least that much too, right? What if your new design doesn't achieve that much? You go, oh, dang, my new design is some trash. It does not do what I need it to do. But I know that, my competition is 3 weeks out. And I looked at this other robot and, the meta robot, I think it's okay, but I can change the way they do their intake because their intake is too slow. And, their tower is too big and their wheels are too far out. How much time would that take you? If you know that making those changes to that robot takes you 1 week or 2 weeks, then you can make the decision then and there that goes, boom, we are switching our robot. We are going to make this other robot that is similar but better. And I know exactly how much time it's going to take me, right? So keep that in the back of your mind, because that's going to be a good decision-making tool for being time sensitive and like making time valuable choices. Add features to differentiate. So this is like a theory that I personally have, where I think that, when you're at Worlds, all robots will more or less look very similar, right? For the most part, they're the same. But what makes a specific robot better than another robot is the features and functionalities, the specific implementations, and maybe a few design tweaks, right? So a lot of you guys, like if you look online, there are a bunch of people who are explaining the robots. Understand those features and understand why they made those decisions can make them so much better. If you just build the base robot that you see released on the RI3D, that's fine, but you should try and add to it so that you can be better. If you're noticing that this robot is good, but it can't perform in the autonomous because, the intakes are too loose, why don't you add a feature to help you do that? Why don't you add a feature to help you do other things? If you look at all the robots, if they look the same, but yours has this extra small feature or even extra large feature that gives you an additional functionality or better performance. You should add that feature, because now everyone is just building, the base version of that meta or design converted robot, and you're building more than that. You should build or add something that makes your robot inherently better than the other robot, so that when it comes to a line selection, you can go, all right, well, you should pick me because although they have that robot and I have a similar robot, I also have X, Y, and Z that makes it better for me or makes me score points faster or better, whatever you might think, right? So adding features is definitely a thing that I think is a good thing to do. Yeah, like Q blocks. Yeah, that's a great point, right? So Q blocks were a great feature to have. So thank you, Gina, for letting me that. But yeah, like if everyone built the same base robot and they're just like, boom, this is it, I'm calling it my season, I'm going to build this robot, then you can achieve something. But adding Q blocks was one of those features. It was something that inherently gave you an upper hand when it came to scoring in those towers, right? You are doing better because you saw a robot, you saw a weakness, and you took advantage of that. Someone said Mechanim Drive. I'm going to kind of like qualify that statement because there's never been a Mechanim Drive world champion. But yes, additional functionality and mobility is a good thing to have. So like to talk about the complexity, because Joshua asks, what do you think about more features versus complexity, where more complex robots have more failure points? That's a great question. More complex robots will have more failure points, but like, trust me, when you're at there's going to be a level where you don't need features, and that's going to be your maybe your local level, maybe your state level in some states or whatever it might be. At the world level, I think you definitely do need to be, differentiating yourself from other robots, and that's going to be where there is a lot of failure points. But you need it's going to be your implementation, your meticulousness, and how well you build that and how well you thought about it that prevents those failure points from failing. So yes, there are going to be a lot of fail points, and yes, best of one is merciless. And if you lose because one of your failure points failed, then darn. But you need to be very meticulous in adding those features, because if you got to bite off a little, and it is a bit of a gamble to add another feature, but if that gamble pays off, or if it doesn't pay off, you can gain from it, right? If it pays off, then boom, you just did better. You just scored more points. If it doesn't pay off, let's figure out why it didn't pay off. How can I make this fail less? So yes, more features are more failure points, but it is your job to, be better and try and minimize the risk of failure by having a checklist, by having, a better implementation, by making sure you check it before every match. So boom, right? So I hope that kind of touched on design convergence. We're now going to talk about making a good autonomous. Could you consider elegance, finding the least complex and most effective way to solve a problem? Yeah, so the balancing act of, minimum work, maximum effect, by the way, that's the definition of efficiency, is elegant. Yes, it's elegant. And it's good to minimize your work and maximize your output. But at some point in time, you need to put more work in so you can achieve more than just the base level robot, right? If you're going to be the world champion, you're going to put that extra work in to be the world champion. It's more than just saying you want to do it. It's stepping up to the plate and saying, hey, this robot's good. It needs to be better because, everyone else can do that too. But yeah, so now we're going to talk about making a good autonomous. And you might be wondering, why are we talking about making a good autonomous when we're talking about early game stuff, early season stuff? Making a good autonomous is a huge part of the early season, right? Like Kai mentioned, every game has an autonomous, and you need to take advantage, or else you're not getting those points. Excuse me. Yeah, so every game has an autonomous. It's increasingly worth more points. So I don't know if you've noticed the trend, but every year's autonomous, autonomous used to be, I could pick up my robot and I could move it as long as it's on the tile. And that's like, kind of autonomous. But now we have, you can't touch it at all. You can't interact with the sensors. You can't interact with your opponent's autonomous. It's a huge key point that VRC is trying to highlight. REC wants you to learn how to code, and you're going to learn how to do it, right? It's a huge point. You want to take advantage of it. Yep. And so having a good autonomous helps you tear up that early season. Although autons that are technically autonomouses are out there, there are those that define victory, right? So two types of autons. I technically have an autonomous. It does move. It does move the intake. I have an autonomous and it scores 55 points. Two totally different spectrums, right? The two totally different ends of the autonomous spectrum we got. So you want to make sure you're making a good autonomous because, early season, everyone's developing. Everyone's got robots that aren't fully tested. Everyone's got robots that have flaws. But if your robot has flaws, but a stellar autonomous or a better autonomous than, you know, the next person, then you're already ahead of the curve there. You are going to get those autonomous points. And when we're talking about early season, losing the autonomous bonus is a gap you need to fill. You know, as soon as you lose the autonomous, you are immediately playing the catch-up game. And what playing the catch-up game means is you either need to score more points per second than your opponents or accept the fact that you're losing. Because you either, if you lose autonomous and you are now scoring at the same rate as your opponents, that gap of autonomous is just going to be continuous as your points increase, right? If you score at a higher rate than your opponents, then as that gap goes, you're going to catch up the gap and then overcome. But you don't want to have to do that work. You just want to be ahead and stay ahead. So having an autonomous that gives you that advantage, you know, maybe that means not implementing another part of your robot. That's fine. You know, early season is a long period of time, you know, long for some regions, short for some other regions, but you should take advantage and definitely maintain the lead just so you can get that state qualification, right? Early season, let's say that your robot isn't super stellar, but, you know, your autonomous is. Boom. You've now locked in a state, like a berth to your state championship, and now you can spend more time making your robot better. You know, use all your time with autonomous. Please do that. There's so many people who just like have an autonomous that'll do something and then disappear. And I'm like, all right, you have 10 more seconds. You can definitely do something, even if that means just placing your robot better so that at the beginning of driver control, you can hit the button and you can pick up all the points too, right? That's a thing you can do. Please be efficient with your time usage. You know, people will say that, you know, well, I scored all the points I did, or I made all my motions. What else do you want to do? You can be more efficient with your motions. At the world level, you will not see a single second being wasted by any one of your world champions, right? You'll notice that if I can do something in parallel, I'll do it. If I can save a second by, you know, doing this in a different order, I will do it. Because again, this is how you set up the rest of the game. Every game begins with autonomous, and that's how you prevent yourself from falling behind. You want to be efficient and use all your time. You know, be ambitious to begin with. So I would recommend a minimum of 1/8 of all the points. And that's because if you look at autonomous, we're talking 15 seconds followed by a minute 45. If you add that up, you got what, 120 seconds, it's 2 minutes. At 120 seconds, 15 seconds of that, that's 1/8. To be truly efficient or to be truly worth your time in autonomous, you better score 1/8 of all those points that you're going to score that match, right? Or else your autonomous was inefficient. Your autonomous objectively was not worth the time you put into it. So, you know, if you want, you can focus on autonomous a little bit more early season. If you want, you can focus on driver practice early season. They both help you differentiate. You know, technically, if you think about it, driver control is a longer period than autonomous. But if you're lacking in driver control, you can make up with that with an autonomous. If you're lacking in autonomous, you better be good enough in driver control to cover the gap and be faster per second than your opponents. Yeah, so you can like you can focus on driving and everything, right? Like that's your call to make. I'm not going to tell you how to run your season, but I would definitely recommend you think about it more than an afterthought. Be realistic day of competition and have an emergency autonomous. So there are a lot of teams that'll say, well, my autonomous is pretty good. You know, I'm just going to run it every match. And then you get that one alliance partner that literally only has an autonomous that works right where your autonomous works. You need to have another autonomous, or you need to have something else you can run so you can maximize your points, right? You don't just say, hey, you know what? No, don't score your points. We're going to be the only ones that score points. You're literally scoring less points because you didn't have an emergency autonomous or something else you could run, right? So emergency autonomouses are literally like as simple as going forward and backwards. There've been so many times where I'm at a competition and my autonomous doesn't work perfectly and I need to tune my autonomous, right? And I don't have enough time to tune my autonomous until the match begins. And that autonomous might just cross the autonomous line. I might just lose my autonomous because of it. What do? I make the intelligent decision and say, hey, this is not worth the risk. I'm going to run my emergency autonomous that only scores this many points, and I know it works because it's simple and it works every time. I'm going to run that one, right? And then I can run my more point-heavy autonomous when I know it'll work and when I know it'll fire on all cylinders. But until then, I'm going to run my emergency one. Also, be realistic in the sense that a lot of you guys are riding your autonomous day of the match or day of the event, right? If you didn't spend 2 weeks riding your autonomous and it's like the day of competition and you're like, boom, I'm going to write whatever autonomous during the competition. Perhaps be realistic and understand that you're not going to make a 50-point autonomous across 15 minutes. You can make a 10-point autonomous across 15 minutes and achieve that and work up from there. but you shouldn't like be immediately off the bat saying, I'm going to get all this. You know, get something that'll get you through the early matches. And if you have enough time, add to it. And give yourself at least 10 hours to make an okay autonomous. Please note that I said an okay autonomous, not a stellar autonomous, not a wonderful autonomous, but something that'll get you through, right? 10 hours is a good amount of time for you to just sit there and go step by step by step by step iteratively and making sure every piece is good, right? So it's a balancing act between punching hard and making sure your punch connects, right? 10 hours, that seems like a lot of time, but when it comes down to it, you need to look at your consistency and you need to look at how many points you put up. You know, you could swing as hard as you can in autonomous, but it literally means nothing if you miss, right? If you have this tall stack of towers, if you got 15 cubes during your autonomous, but you didn't put them in the goal zone, you didn't score any points. You scored 0 points, right? And so although it's easy to say, well, that's okay, right into driver control, I'll put it up, you still lost the bonus and you still put yourself behind. Yeah, so, you know, if your emergency autonomous is just driving forward, pushing the cube into the goal zone, backing away, so be it. But at least it's something more than just sitting there, right? And know when some things are out of your control and please try to account for them. You know, that might be a hard question to ask, like, well, if it's out of my control, it's out of my control, right? But some things are out of your control, but you can account for them. If you know that, you know, your turning function isn't perfect, or there's some level of error in your gyroscope, or, you know, there's some level of error in your lift, maybe use the wall to help you align, right? Drive forward, turn, back up into the wall so it lines up, and then drive forward again. You wrote 1 extra line of code, maybe 2 extra lines of code, but you made your autonomous so much more efficient by doing that, right? So much more, accurate by doing that. So if you can do that, go ahead, calibrate your sensors, do whatever you need to do. But you have to kind of spend a lot of time getting those techniques down so that you can make sure it's consistent. All right, so if we're talking making a good autonomous, let's start from the bottom, right? So before you make a good autonomous, you need to know what coding platform you're using. I prefer Pros. Some people like drag and drop. Some people like VEX Code. Some people like VEX Coding Studio. I disagree with them, but that's okay. Familiarize yourself with its library, commands, and syntax and power. Every library, every platform you choose to code with has its own advantages, has its own disadvantages. Make sure you are familiar with that. Make sure you understand how to use that library, because you can save so much time by just, knowing the functions, knowing the way to do things will save you a lot of time. Pull up the API, read through that. Make sure you know what functions do what and how they work, because once you know that, it's just in your head. You're just putting things side by side and you're making it autonomous a lot faster, right? So for me, like one of the things I messed up with was like learning to use the Okapi library in Pros. I was like, boom, I'm going to use this. It's going to be great. I spent a lot of time, not being able to successfully use the Okapi library because I didn't spend 5 minutes reading how to use the Okapi library. And that 5 minutes would have saved me like 10 hours. So definitely really good to familiarize yourself with that. Look at an example of how to do new things. If you're exploring some new type of code, please look at an example. Please try and like do that, please try and just spend some time reading up on what an example would look like, because it's really hard to kind of come up from nothing. And although you can try to kind of, do whatever you want to do, it's always helpful to look at how has a successful version of this worked. Use all the sensors you can, however you want, and parallelize if you can. So, I prefer doing a multi-threaded approach just so I can have a lot of different sensors being checked at once. I prefer having all that because at the upper levels of competition, you got to have all the sensors you can, right? And you don't have to necessarily use the sensors in the traditional way. Like me for, for turning point, right? So for turning point, we used line followers everywhere so we can detect the ball in the robot, right? And so what we had was we had one line follower at the bottom, one line follower at the top, right? So once the line follower counted 3 balls, our intake would stop intaking from the front. Our next intake would go to the top, right? If the line follower sees a ball in there, that means that, the ball is ready to be loaded, and there would be a third line follower at the barrel ready to shoot. So what we could do is we could automate that process. We could say, if I push a button, shoot, and there's a ball in front of the launcher, shoot. And then once there's no longer a ball there, keep intaking until there's a ball there. And if there's a ball there, shoot. You've just automated your firing function. And by a press of a button, you've scored like so many points, right? Automation is a lot of cool things that you can do. So use examples as a guideline, not your autonomous. There's no good examples. So like you have like good examples, as Kai mentioned, that are like good to get you started, but they're not going to be your whole autonomous, right? They're not made for your robot. You got to make them better. balance is between speed and precision, and you can do that by tuning, right? So you can be super fast and use every second, but you might miss every point. To get all those points, you need to kind of be accurate about that. Yeah, so recommend teams design and plan your autonomouses like you would for any robot. Be prepared. Test each function iteratively and then add to your autonomous. So if you made a bunch of functions, before you start using them in your code, just write your whole autonomous, test one function, test your turn. Does it work? Okay, test it 3 times. Does it work accurately? Okay, how can I make this turn function the best turn function I can? Cool, this turn function is not the best turn function I can. Let's talk about forwards. Is this forwards the best forwards it can be? Is this backwards the best? When you have, the best group of functions you can now make the best autonomous you can because your functions work, right? And then you iteratively add to your autonomous. You go, okay, I need to drive forward to these cubes. Test it, forward and intake. Okay, forward and intake didn't go forward enough. Okay, I'll add a little bit more forward. Okay, that's the right forward. Now I'm going to add another. You don't want to write your whole autonomous and just, shotgun approach, see what happens. That's going to lead to a lot of mistakes you don't know where are coming from, right? They're going to be inaccuracies you can't account for. And, if you experience something wrong, don't make an immediate change. If you notice that, oh, you didn't go far enough forward, run that same piece of code maybe like 2 more times, right? There can be consistent issues that exist, and there can be just like one-off mistakes that you don't know where it come from. So you want to identify, do I need to make this turn a faster turn? Do I need to make this turn more? Or was that just because, there wasn't the right amount of grip on the field? Or, 1 out of every 10 times it'll make this mistake. You don't want to just like shotgun random changes until you see the correct motion, or else you're going to spend a lot more time making changes and a lot less time scoring points. Make sure your last autonomous motion is driving backwards. So this is like, just take it contextually. This year, if you think about it, everyone picked up all our cubes and we went to score on the tower and they just kind of stood there, and you've got like 1/8 of a second more. Even if you have like 1/8, 1/4 of a second more, just make it go backwards, man. Like you could potentially be touching those scoring objects and that last second, and just an 1/8 second of going backwards like disconnects you. Like that's all it needs to do, right? So just do that, and it would definitely prevent you from not getting any points because you're touching those cubes. Don't rely on luck and add to your design if you have to. So if your autonomous physically can't do something and you need something to happen, maybe you need to add to your design just for that autonomous, right? If you come back to, what can I think of? If you think of in the zone, right? It was really advantageous for your opponents to miss their autonomous. And if they miss their autonomous, the rest of it was thrown off. If you look carefully, if you look at some of the robots had design mechanisms that literally threw a cone across the field into the path of their opponents. Now, although this is now illegal because you can't interact with your opponent's autonomouses, at the time that was legal play. And what that does is that says, hey, I'm not going to rely on the luck of my opponents missing. I'm going to make it happen, right? You need to make sure you're in control. And if you need to score another point or you need to get another game object by doing some special motion, consider adding to your design just for the sake of autonomous, because that autonomous bonus, like I said, goes a long way. Yeah, so there's that. Know what to achieve by what time frame in the season. Understand that, maybe your best autonomous is a week before Worlds. Know that you should be shooting for that goal kind of like consistently throughout the season, but, have kind of break points. Know that if by your state tournament, you know that the best autonomous in the world by your prediction is going to score 35 points. Maybe by your state tournament, make sure you're scoring at least 25, right? Have these kind of markers there ready for you so that when you're at that point, you can go, oh, shoot, I'm not doing good. Kai, what do you think about that?
So one of my points about autonomous is consistency. Consistency matters a lot. It matters when I was competing, and now it matters way more that I'm coaching. So a good guidelines for it is if your autonomous works 8 out of 10 times, I would not change it. Those 2 times, I would just consider it as like an anomaly. If your robot only works once out of 10 times, you definitely need to change your autonomous, however. And also, there's a problem of consistency that you have a field set up at your school or at your private home or at your private team or whatnot. That field is unfortunately not going to be the same exact field as when you go to competition. So you got to account for that as well. There might be some configuration issues, or maybe you have to recalibrate your robot once you're at competitions, but you also have to, account for that as a consistency matters as well for your autonomous. Because there are some teams that, go to competition and say, well, my robot works all the time at home, but it doesn't work here. And then, you can't really complain about how the field is set up. So you gotta put those into consideration as well.
Yeah, that's a great point, right? We got a 1-inch tolerance. Make sure you're aware of that. Yeah. All right, so now what we're going to do is we're going to break down a game, Champions Bridge. And you might be thinking like, wait, that's not a real VEX game. Yes, I get it's an April Fool's joke, but it's a great example of how to break down a game that no one has played, that no one has had anything to do with, this is a great example. So we only have 7 more minutes left in this session. So most definitely we're going to go over a little bit. The way we're going to do this is if you need to leave in those 7 minutes, that's fine. I get it. I'm going to keep pressing through and, going until our game analysis is done. We're going to do a quick speed round, right? So what that means is I'm going to watch the video because I haven't watched it yet. I kind of like watched it. And then I'm going to pull out the notes and I'm just going to do what I would do when I first see a game released, right? And this is going to be a great example for you guys as to what you might want to do when the game is released. So it's going to be going a little fast, but I'm going to be writing it down. If you have any questions, feel free to kind of ask Kai or in the, in the private chat or in the everyone chat, and Kai will address them as I kind of am shooting through, right? So, let's do this. Let's stop the share. Let's go share screen. Let's go my screen, share, all right here, exit. All right. Oh wait, now I have to change the share setting. That's right. Start share computer sound, and screen done. There we go. All right, so we're gonna watch Champions Bridge game video real quick, and then we're gonna do a lot of analysis.
To the world's greatest 2 minutes in robotics.
The 2020-2021 game VEX Robotics Competition Champions Bridge. Champions Bridge is played on a 12-foot by 12-foot field by 2 alliances, 1 red and 1 blue, made up of 2 teams each. The object of the game is to get more points than the other alliance by scoring trophies and bases on podiums and either parking or hanging.
All right, so right off the bat, I've noticed, if we're talking points, and these are notes I would be normally taking as the video plays, but I can't do 2 things at once, so I'm sorry. So our points come from, our trophies and our bases and parking. Right, so those are 3 things I'm going to be paying attention to while I read the rulebook. I'm going to know that I should be looking at those point values.
The VRC Champions Bridge field contains 25 trophies.
Okay, cool. That's another important thing. So under trophies, I've got 25 of them.
And 4 bases.
Cool, 4 bases. Going to take a note of that one. Ooh, please. Oh, no. Perhaps not. Okay. Let's see. Where's my eraser on this? Oops. I'm just going to hit Control Z. There we go. Bases. I got 4 of those. Cool. Keeping that in mind. Or wait, did I say 4? Yeah, I said 4.
On the field, there are also 2 podiums, 1 per alliance, and a bridge. Trophies are not.
All right, so 9.75 inches. So if I'm looking at trophies, 9.75 inches. So you guys might be wizards with like dimensions. I am not. So when I look at this game, I'm getting hella in the zone vibes, right? But I want to find some equivalent understanding of what 9.75 inches are. What 9.75 inches looks like to me is going to be Skyrise. So what I do is I go Skyrise game manual. I go Skyrise game manual. Boom, we're looking here. We go, okay, well, these kind of look like roughly the same size of cubes, I would guess. So I go to the definition of a cube and where is it? Cube. Okay, so cubes are what? We're looking at 8 inches. Okay, so now I know that a cube is about 8 inches. So roughly I should be expecting, I should be roughly be expecting about a little bit more than a cube. So, just a thought in the back of the head is greater than cube size from Skyrise, right? So now I have a rough idea. I don't know what 9.75 inches or whatever, but I know a cube from Skyrise is this big, and now this object is that big. I now have a kind of an understanding of what that is, right? A respect for the size. What did I do? Oops. Oh no, whatever.
9.75 inch or 247.65 millimeter triangular pyramids that weigh 1.75 pounds.
Okay, so 1.75 pounds. Now I know how much, please go away. Now I know how much to kind of expect these to weigh, right? If I'm making a mechanism, I need to know how heavy these objects are. So the cube, I said 1.75 pounds. Cool, 1.75 pounds. What does a cube weigh roughly? Does not say. Cool. Skyrise cube weight. Oh, cool, 1.12 pounds. All right, cool. Answered a while ago, hollowing plastic, 1.12 pounds. All right, so I know that when I play this game, I need to understand that, if I look back to Skyrise, people had, 4-motor, 6-motor lifts, and those are the old motors, so I should be ready to expend, maybe about half that many motors on these designs. So 1.75 pounds, which is greater than our Skyrise cube. So, if I'm looking for design inspiration in terms of motor counts and such, I can look to Skyrise, but understand they're going to be a little heavier than Skyrise.
And are worth 2 points.
All right, 2 points. So cube, Skyrise, all right, our cube is 2 points on low.
On low platforms, 5 points on middle platforms, and 9 points on high platforms.
Okay, so I'm looking at 259. All right, so, here's what I'll do. I'll go, where's my eraser? Is this the eraser? I think this is the eraser. Nope, definitely guessed wrong. Cool. 2, 5, 9. That's a 9, yeah. 9 points. Cool. So that's roughly about a point. I'm going to keep that in mind. I'm going to do a max game score after that.
Bases are 11-inch or 279.
11 inches. Okay, so how big is 11 inches? So when I think bases, I think, what, in the zone? All right, so I'm going to go here. I'm going to go in the zone game manual. In the zone game manual, go to mobile goal. Mobile goal, 10 inches. Oh, that's the height, excuse me. Base diameter, also 10 inches. Cool. So, 10-inch base diameter. These guys said 11 inches. So I know to expect from the bases, I'm going to expect like greater than our mobile goals, right? So now I have rough ideas. Like, I don't know what 10 inches is like inherently, but I have a rough idea of how big things are relative to one another, right? From previous games I've played. So I can kind of like rely on that. Said there was a chat. Nope. Kai, if there's a chat question, could you please answer it? Because I'm seeming to be lacking right now. Oh, 11 inches is 11/8 of a ruler. Thank you. All right.
0.4 millimeter cylinders that weigh 3.5 pounds and are used to hold trophies. Putting a trophy on a base doubles its points.
Okay, that's big. Putting a trophy on a base doubles the points, right? So these aren't just like points, these are multipliers. So I need to keep in mind that these are multipliers. Man, I gotta get a tablet to write this stuff.
Additionally, taking trophies and bases from your opponent's podium is allowed.
Okay, so we've got legal D score. So, just like a note up here, kind of D score is legal. So maybe I just kind of wait. Maybe I could just wait for my opponent to put their things up and I just kind of like steal them.
And no object carrying limit exists.
No object carrying limit. Cool. D score legal. Carry limit not applicable. All right, that's good. That means I could play Evil Santa. I could just hoard as much as I want. All right, good note to keep in mind.
There are 3 different positions for which a robot receives points at the end of the match: 2 parking positions and a hanging position. For a high parking, a robot must be on top of their highest platform and will receive 25 points. For bridge hanging, a robot must be hanging on the bridge completely off the ground and will receive 8 points. For bridge parking, a robot must be completely above low bar, only supported by the high bars, and will receive 25 points.
All right, so that's kind of weird. So from the park, it's 25 points, 25 points, and 8 points. What that tells me is I am most definitely not putting my robot on top of those like towers or whatever. I'm not having my robot just sit on those like PVC pipes for it to fall off. Like that is not happening in my book. So 25 points, it's worth the same amount of points, and it seems like it'd be like infinitely more work to have it balance itself on those. So I'm just not doing that. It's worth the same amount of points. So not worth it.
Each match begins with a 15-second autonomous period where robots score on their side of the field without help from their drivers. The alliance that scores more points in the autonomous period is awarded with 6 bonus points, added to the final score at the end of the match.
The 1 minute 45.
Okay, so I've got Auton. All right. Ooh, did I start at the bottom? I mean, I did it again where I started at the bottom page. Whatever. So Auton is 6 points. Okay, that's good to know.
Second driver control period begins once the autonomous bonus winner has been determined. At the end of the driver control period, after all objects and robots have come to rest, the match will be scored to determine the winning alliance. Remember, VRC games are not scored until the driver control period has ended.
All right, so that's pretty interesting. You know, it gives me a lot of ideas. Didn't say that the robot has to be above the bottom pole and fully supported by the top one. Yeah. So, hey, maybe I could look at, like, you know, what is the definition of being kind of fully up there, above the bottom pole and fully supported by the top one? Yeah, so actually that's a great point. Whoa, that might be easier. Yo, you're so right about that. So great point brought up was, you know, although these 25 points are from being on top of that top tower, or excuse me, that top like PVC pipe, I might not have to be fully up there just balanced. I might just need to like have a claw or like some hook mechanism that goes up there and pulls me 1 inch off the ground. So that is a great point. I'm not going to dismiss these points just yet. As soon as I figure out how to erase, I can erase it, I swear. Nope, that wasn't it. All right, cool. We're not going to try to erase it. Oh, wait, this is an eraser. Oh, that was an eraser. Cool, cool, cool. Yeah, so that's a great point. So now I have some now I'm kind of primed, right? I'm kind of ready to read the rule book. I'm ready to say, hey, you know, this is what I'm looking at. So let's figure out what the definition of score is. Let's figure out what we're looking at in our game manuals so we can get a better idea of, you know, what's going on. Ooh, more chat there. I'm noticing the five of the trophies are on top of the bridge. They'll be harder to grab, but once you have them in a good position to put them in the top podium, these points would be worth it. Yeah. So, you know, 5 of the trophies are on the top of the bridge. They'll be hard to grab, but once you have them, you're in a good position to score them. So it's a good point. You know, maybe you wanna commit to going up there because they're worth so many points. So here's what I'm gonna do. I'm going to move this, go here, go here. There we go. We've got our rule book for our game. So now that I've kind of best I climb the top and then extend arms and just D-score. Yeah, it's possible. So let's go through here. We've got, okay, so we know we're going to be standing from our diagonal perspective. So that's a good thing to keep in mind is if you're a driver, it might be very hard to see your robot behind your opponent's kind of pedestal there, right? So keep that in mind. It's going to be difficult to do. Okay, so we've got our bridge alliance podium. Yep. Autonomous line. Okay, so there is an autonomous line, which means I can't be messing with, you know, we can't be messing around with the other opponents autonomous during the game. So whatever points are on our side, we got to kind of take that as it is. All right, so line station, autonomous line, yep. Autonomous period, 15 seconds, base, yep. Bridge, low bar, PVC pipe, 20 inches. Okay, so we know that our low bar, I'm just gonna go to the top. So from here, low bar, so our low bar is what, 20 inches off the ground? Yep. Oh, come on. Okay, so 20 inches off the ground and 34 inches off the ground. Okay, so that gives me a rough idea of how tall I need to be. So what I say, 20 high bar. What are we looking at? Like,
Hey guys,
34?
I understand that we're a little bit over time, but if you would like to, you know, drop out of the sessions, you're more than welcome to. But if you want to stay and continue with the sessions, we're going to be here until Afnan's finished.
Yeah, I'm sorry about that, guys. I definitely did not appropriately plan my time. I apologize, but we are going to be pushing forward. So if you have to leave, totally understand. This is recorded. You can watch it later. Like, comment, subscribe, you know. Yeah, so going through it, bridge hanging. Okay, this is a great. So a robot is considered to be bridge hanging if it is only supported by the low bar and not contacting the foam tiles. All right, so I know what, you know, a low hang, which we mentioned was worth how many points? Like 8 points. So low hang, 8 points. I literally just need to be like low bar, just supported by the low bar, right? So is only supported by, only supported by the low bar. So only supported by low bar. and off the ground, not touching the tiles. All right, so that's a good thing to know. It might not be too hard to get. Maybe if I'm running short in time for my autonomous. Is this the real game? No, this is not the real game. Don't be confused. This is not the real game. This is the this is our this is like April Fool game they posted. We're just breaking it down so you guys have a great example of how to break down a game for when you see it on Saturday. So this is like a great example of what you should be doing, right? So bridge park, right? Robot is considered a bridge park if it's only supported by the high bar. It is completely. It's got to be completely above the low bar. Okay, well, okay, so maybe like some sort of like grappling hook thing that deploys like this or whatever, hooks on, pulls you up, maybe, I don't know, but it doesn't seem like I have to be physically on top of the bar, which is great. So that might actually mean those points are worth taking. So high hang is what I'm going to call it. And that is, what do we say? That was 25 points. And, you know, you just have to be above our low bar. And what above low bar, and what else did it say? Bridge park is only supported by a high bar and completely above. So only supported by a high bar. So, you know, only supported high bar. Cool. So that makes sense. So maybe that is worth getting, actually. If the autonomous period ends in a tie, each alliance would receive an autonomous bonus of 3 points and 1 match load. Oh, there's a match load. Okay, wait. So autonomous bonus has earned the most points. I thought it was six points, all right? And 2 match loads. Oh, wait, what? So that's big, right? Because each one of these platforms, or each one of these little like triangle trophies, as they're called, are worth what, like 9 points, with the potential of being doubled to 18. And I get 2 of those. That's like almost 40 points. All right, I'm definitely winning autonomous. That's what that tells me, right? So I missed that in the auto bonus at the bottom. So auto bonus is 6 points and 2 trophies, which is worth roughly, you know, 18,236. So 36 points. That's like a lot of points. All right, that's good. I'm playing to win autonomous. That's the game plan now. All right, disable win. Okay, that's the same qualification. That's the same driver control. It's the same. You know, match 2 minutes. Yeah, match affecting. Yeah, that's clear. Park. Okay, robot status is considered parked if it is only supported by the alliance high platform or completely above the high. Okay, so this is perhaps so it is only supported and completely above its alliance high platform. Okay, so this one is actually looking to be more difficult than the other one because your robot physically has to be up there, right? Like the other robot, because like that's like a really tall place to be at, and you got to figure out how to get up there. But the other one is just like being off the ground and above it. I feel like it would be more effective to somehow launch the trophies under the top podium rather than climbing up there. It looks hard to climb up there. Yeah, it looks super hard to climb up there. So maybe we can do some sort of launching mechanism. Maybe we can do some sort of like placing up mechanism, but we don't care about mechanisms right now, right? Right now, we care about what are the points, how hard are they to get, and how many points do we need to win. So placed, okay, so this is good because this is going to tell us how we get our points. A trophy status, the trophy is considered to be placed on the platform at the end of the match if it meets one of the following criteria. One side of the trophy is resting flat on the platform, one side of the trophy is resting flat on the base that is resting on the flat platform. Okay, so looking at the pictures, 2 trophies placed, 1 trophy is placed. Oh, 1 is not placed. Okay, so you can't just like in the zone stack. You need to have them separately on that. Okay, so that's big. That means that I can only multiply it 4 times, right? So there's a limit on our multiplication. So going up here, so, you know, I guess like a note on being scored, your pedestal, your little like trophy has to be on that platform. So you can't just like, can't in the zone score. It's like kind of different in that sense. And that also means I can only multiply. Oh man, I wish I wrote that better. I can only multiply 4 times. All right, I've noted that. Only multiplying 4 times. 1 to the 10 platform, 1 to the 10-dimensional surface. Yeah, I don't care. Podium, tall stair-shaped sucker containing 5 platforms. Yep. All right. Post. The post is. Wait. Oh, the post we actually put the thing on. Okay. I mean, that's not too big of a deal. Like 9 inches. Or what is it, like? What do we say the length was? Like what? 9.75 inches. That's big enough for a 2-inch. You know. Hole. We're fine about that. Preload. Oh wait, okay. The trophy, 1 per robot that must be placed. Oh, so there is a preload. All right. So under Auton, there's a required preload. So using that required preload, I definitely want to maybe put it on top of the very tall one and maybe put a base under there to get the 18 points to potentially win the autonomous. So that's like a thing I might want to do for my autonomous routine. Team, traffic, trophy. Yep, we're familiar. Trophies. Oh, okay, cool. This is good. Scoring. So let's look at our points, right? So on a low platform, 2, middle 5, high platform 9. Oh, wait, okay. So based on a high platform. So this is an interesting thing. If we've noticed the fact that these trophies only count if they're directly on that platform or they're on a on a high platform with the base as well, then we get the multiplication, right? But we can only multiply 4 times, and it has to be on there. So let's look at how big this like platform actually is. Does it say platform? Okay, so we're 36 wide, 36 wide, 24 long, 24 inches long, 96 inch, 24 wide, 36 tall, stair-shaped structure containing 5 platforms. Wait a minute, what? So it is like 96 inches long, 24 wide, and 36 tall. Oh wait, 36 isn't that bad. It's like 3 feet. That's not too bad. Okay, stair-shaped structure. So we do know how wide it is, right? So we know that's going to be 36 inches wide, and we know that our base platform, or our base, how big is our base? And that's our base is what, 11 inches? 11 inches on a 35 platform order, podium. What if you just played defense? It seems like it would be pretty easy to keep people from climbing up podiums. Yeah, it's possible. There's probably like definitely rules to keep you from like just like knocking your person off the platform for like safety purposes. So I'm sure there's some rule in there like it is 26 wide and 36 tall. Yeah, so it's 24 wide? Oh, 24 wide. Thank you. 24 wide, 36 tall. Okay, so 24 wide at 11 inches means I can only place 2. Realistically, I can only place 2, like maybe 3 if I like do it right. Like I need to know what the width of that is. That's the problem, you see. So like keeping in mind roughly, so for our multiplication, we can only multiply 4, and we can get 2 to 3 per rung. I know I cannot do 4 unless I'm like really, I really finagle that. So 2 to 3 multiplications on the top point. What that means is I can do 18 times 3 on a max. So let's see, what are we looking at? 18 times 3, we're looking at 54 points off that. 54 points off that. If we now do our next base, but the bases are only so big, but I got 2 of them. Okay, so with the bases at, what is it, 9.75? Yeah, 9.75 inches at 24-inch length. I can do 9, 18, 27. I could probably finagle and get 3 on per platform. 3 on per platform. We're looking at 1, 2, 3, 4. So what, 12? So 12 of them I can put on platforms. So I'll do what, like, we said they were worth what, 9, 5, and 2 points. So I got 54 points there, plus my, what, I can put, like I said, 3 on per. So if I can put 3 on per, I get what, 3, 6, 6 multiplied by my 9, no, 6 multiplied by my 5. So 30 points from there, right? Oop, please, where's the chat? Yes. Where do robots start from? That's a good point. It did not specify our autonomous starting position. So we can look into that, but I need to figure out how many I can do, right? So I got 30 off that, and I do 6 more times 2. 6 more times 2, so I got 12 points, plus I've got my 6-point autonomous. So all in all, I'm looking at 54 plus 30 plus 12 plus 6. Oh, and I didn't even add my my high hang, right? So that's another 25 points. That gives me 100 points. So roughly I'm looking at, like, if I'm maxing out, oh, well, I guess like you can hang twice, right? Because 2 robots can technically high hang, I guess. So we're looking at another 25. We're looking at 125 points. All right. So that is our, like, really quick. I didn't even look at it like in a lot of detail. We're looking at 125 points maximum, which means I need to achieve 125 divided by 2, 70. What did I do? 125 divided by 2. Oh yeah, 62 points. So 62.5 is what, our magic number. 62.5, which goes to 63. Is if I get this many points, right? Let me undo that. Let me like highlight that or whatever. If I get this many points, I have won, right? I physically cannot be beaten because that is more than half of all the points available on the board. So I'm keeping that in mind. My next goal is going to be figuring out how to get those points. Safety rule. Okay, cool. Safety's cool. Safety's important. Safety's important. Safety first. Let's see. Don't destroy other robots. Okay, on counter defense. Oh yeah, so there might be some problems, knocking teams off their platform. Yep. Players are allowed, but replays are, yep, that's clear. Specific game rules, start of the match, part of the start of the match, or place stitch the content if you're playing wall. Okay, so we've got same autonomous beginning as, for tower takeover. So we're looking at that. I'm looking here, contact podium, not contacting the base. Okay, so I can't contact the base on the beginning, so the base over here I cannot take advantage of. All right. So stay on your side during the autonomous. That makes sense. You know, stealing game elements from your opponent's podium is legal. Robots must take freeze. Yep. Don't push the robots out that are off. Oh, okay. So I cannot contact a robot once it is on their platform or on their bridge or okay. So, you know, if a robot's up there, I can't touch them. That's fine. You know, there's no position limit on game elements. All right. There's no expansion limit. Oh, there's no expansion limit. All right, cool. So no expansion limit, like, just tells me, like, off the bat that maybe my best autonomous move is to, like, go over, you know, go from wherever I begin, move forward, and then just, like, sweep all those onto my side and play, like, some starvation early game. Use game elements to play the game. Yep. Oh wait. So stay on your side during autonomous. So during a I can't touch their podiums on their side. I guess these ones that are in the middle are like a null ground, so I can grab those. So off the bat, what I'm thinking, right? Autonomous, I have to take those 2 podiums in the middle, or else I'm not getting that multiplication. I'm losing what did I say? 36 points. 36 points is what percentage of 65, right? Because 36 points is what I get from there. So 36 divided by 65. I did that wrong. 36 divided by 65. Dude, that's 55% of the points. What? So if I get 3 bases, I'm currently gonna get 36 points, because if I put them on top, you know, the 9 multiplied by wait, what, did I do that right? 9, 18, 27. Why can't I do math? What, did I do that wrong? Oh, I definitely did that wrong. Okay, so so not 3 bases, that's 27, excuse me. So 27. So that seems more. 27 divided by 63, you know, so 42%. That's 42% of all points on the field. If I can get those 3, you know, bases and score them, put like a podium on top of there, and then put them in the top part, I've literally almost won the game right off the bat. So I need to make sure that's my first priority, getting those. No expansion limit, keep trophies on the field. Use game. Yeah. So, like, I haven't even, like, done a lot, but we are hitting our kind of limit here. So if you look at it, right, we've already broken down what do I need to do during autonomous. We figured out what is the maximum point value. We figured out, you know, how many points we need to win. We've kind of figured out some, like, macro play as well, right? Like, I need to make sure that I'm getting the podiums, and I need to figure out why I'm getting these podiums during autonomous. So that's like a whole spread of, like, what I would do once the game is revealed on Saturday. So, you know, I'm not going to go any further than that. I think that's, like, sufficient in give an example of, like, roughly what the thought process is there. But yeah. That's kind of my thought process. I hope you guys enjoyed that. Oh, dude, I accidentally turned off my video too. I'm sorry. Yeah. So that's kind of my thought process there. I hope you guys kind of follow that. Yeah, please keep in mind that this is not the game from next year. We are using this as an example. So, like, don't just, like, run with that and build robots and stuff. But yeah, so that is kind of our approach to how when given a game and just released the game, what should you do? That's what I would have done. So there you go, guys. Hope you guys kind of follow that. Didn't get calls asking for field sets. Yeah. So, you know, hope you guys gained from that. That is the end of my session. If you guys have any questions, feel free to ask now. You know, unmute the mic, ask in the chat, do whatever. I'll be here till about, like, I'll wait for a bit, you know, just to get all the questions answered. But if that's not it, thank you guys. Do you think the mathematical field of game theory would be helpful for this? Game theory is super helpful for this. Like, game theory is how you identify what other people do, and you kind of get into that, like, counterplay idea, right? So when you have game theory, you recognize the fact that my opponents are going to do this because this is valuable. Because they're going to do this because they're valuable, I'm going to counter by doing this other thing, right? So game theory and understanding how points are going to be played and socially how people are going to approach the game, really big here. And you'll see a lot of, like, thoughts similar to that, like, wavelength when you get to the world level, because they understand how the people play the game. No problem. Oh yeah, zero-sum games. Oof. Game theory is huge on zero-sum games. For zero-sum games being, like, you can end up with points going back and forth or whatever, or, you know, having a new zero as per definition.
Hey, this is relatively off topic, but I was just wondering if you thought that the pandemic would have any lasting impacts on the game next year, or on VEX in general.
Yeah, so if we're looking at our pandemic, you know, what we're probably going to experience is, and I don't speak for VEX, I don't speak for REC, I don't speak for your regional, my opinions, we're definitely going to probably see a push into maybe not having competitions until our late time period in the season because a lot of states do have their quarantine. A lot of countries have their quarantines. And as per like a lot of states, you can't have gatherings more than X number, which we definitely will cross if we have a game competition. So you might experience a change up in your early season. Instead of being like, August, your early season might end up being December. Your early season might end up being January, whatever is, the safe approach for doing that. But yeah, this might give you a little bit more time to strategize, a little bit more time to, really dive into the game and understand how it plays, and also look into, doing a lot more scenarios. That's one thing I didn't do in this session was, doing a time analysis of this game and breaking down every timestamp what I would do. So maybe that's something you might want to do. You might want to try with this game or with the game when it's released, saying, okay, match begins, driver control, first 10 seconds I do this, opponent does that. Next 10 seconds I do that, opponent does that. And just play that game kind of in your head meticulously. Yeah.
Cool, thanks so much.
No problem. All right. Anything else?
I have one. So you were just talking about time analysis. My team and I, we've done them, but we've always had them being terribly inaccurate. How would you recommend being realistic with your time analyses?
Okay. Yeah, it's a great question. So with time analyses, it's a really useful tool to understand how you and other people would approach games. And the inaccuracies tend to come from our kind of assumptions that we're not updating, right? So for me, I try to play some safety numbers and I try to do like some understanding, but I don't want my game analysis to be like super like how the game. Ideally, it's best when it's like your game analysis is super accurate with time, but they're definitely meant to get you a rough idea of how the game would play. I would say, if you could kind of set up like a game of checkers, almost like have a board there and you play against your opponent, like physically moving pieces. It takes a lot of experience in understanding, how much time does it take for you to pick up an object? You need to have kind of definitives there. So, and you need to understand what level of play you're talking about, right? When I do my time analysis, I always assume world's level play. And when I say world's level play, I mean like, oh, well, if I was a super great autonomous that would score as many points as I could, I would do this. And I go, okay, let's assume my opponents do that. Let's assume both opponents do that, and kind of breaking down those times. Because, these are kind of thought experiments, you don't always necessarily see the exact outcome. There might be some other like social factor that it influences them. I would recommend going back and kind of how like I looked at Skyrise for a second right there. I said, I know how heavy these Skyrise objects are, and I know that on Skyrise robots they ran 4 motor lifts, so I can expect at least 2 motor lifts on 5 motors, right? Okay, well, how long do you think it would take a V5 motor to pick up an object like this? How fast do you think someone could do it? Just breaking down like time steps like that, like figuring out how much time each action takes, and then maybe saying, okay, well, according to this time analysis, we totally cleared the field in 10 seconds. Maybe this is not accurate. Double guessing yourself and changing the parameters, it's definitely something you have to play with. So I would recommend, looking at previous games and figuring out what time components, as far as, driving across the field, as far as picking up heavy objects, as far as getting to a certain height and elevation, as far as like hanging, like see what like rough estimates of time you can get, and then assume that with like V5 motors now, and now try and kind of approach the game again with that kind of lens. So I don't know. Does that answer your question?
Yeah, thank you. That helps.
No problem.
One more thing about time analysis. This is, of course, just my opinion, and some people might disagree with me. But whenever I do time analysis, I use that as like a best case scenario. So at the very beginning of the season, I wouldn't I would do a time analysis. Hey, it's going to take me, say, 10 seconds of autonomous to do this one task, or maybe these 5 set of tasks. But that's the best case scenario. And you should follow it, yes. But at the same time, if you don't completely follow it, if you just do 4 out of 5 tasks that you plan out to do, that is completely okay. In my opinion, 4 out of 5 tasks is still better than not doing anything at all. So just keep that in mind. Time analysis, I would just use it as a best case scenario. Sometimes you can't really predict what your opponent do anyway. So yeah, just my 2 cents.
Yeah, that's very true, Kai. Thank you. Yeah. So any other questions I can answer? Any confusions I can make unconfused, or, questions on projections for the game, projections for how to approach game breakdowns, et cetera, et cetera?
Would you think that writing down your game analysis on your notebook would be helpful for getting a design award?
Okay, yeah. So great question. Is taking active game notes during the release in your notebook good for getting our design award? So what I would say is I wouldn't write it in your immediate engineering notebook. I would write it in some sort of scrap notebook or like some sort of extra notebook. Maybe it's your like extra chemistry or math or whatever notebook. Just writing notes and actively, paying attention to that, because the breakdown that I just did was my thought process, right? That wasn't just me making stuff up. That was my thought process. Every thought that came to my mind, I wrote it down. And the reason I write that down is because part of the engineering process and part of that design interview is being able to justify why you did things. And some things we just know. We just know that a robot needs 4 motors on a base. We just know that, right? That's an assumption we made. Why did we make that assumption? You need to explore that question, right? Like going beyond just, that's just what people do. Well, understand that there's a reason people do that, right? So when I wrote down, these 25 points, these are too hard to get, I'm not doing it. I actively thought, difficulty, too hard. Is it worth it? Well, it's worth the same amount of points as the other one. So maybe I don't want to do it. Decision. I'm not doing it. And that thought process is, really quickly scribbled down in my notebook or my scrap notebook. But now when I get to my real engineering notebook, I can say, okay, game analysis, because the point value is very similar to the other point value for doing 2 tasks. One is very difficult to do that task. As such, we have decided not to do that task because it's not worth our time and effort. That's a justification. That's a detailed justification as to the decision you made. And it's not an arbitrary decision. You didn't just say you didn't want to do it. You explained why you didn't want to do it. So I would say it goes a long way.
Thank you.
No problem. All right. Any other questions? All right. I guess we're all on the same page. All right. So, I look forward to seeing you guys again next week. Again, if you haven't watched the seminars from previous sessions, please do that. That's super helpful. I would definitely recommend, going through this last maybe 15 minutes again to get a refresher on how to break down the game right before the game. And we'll talk about it next time, right? All right. Later, guys.